I'm going to start today by looking over arithmetic sequences. Arithmetic sequences are similar to linear functions. So arithmetic sequence is a sequence of terms that has have a common difference. And what that means is that you're adding or subtracting the same number each time. And when we're looking at a function, that adding or subtracting same number each time in linear is called a constant rate of change. So when you're talking about sequences, it's called the common difference. But when you talk about linear, it's called the constant rate of change. And since I'm here, I'm going to go ahead and make sure that you understand the only differences between sequences and functions is that sequences start at n equals 1, whereas functions start at the y-intercept where x is equal to 0. All right, so that's the only difference. So, and then of course the words are called different things. So again, common difference is in sequence. In linear, we say constant rate of change. All right, so let's write the explicit formula. So if I come into the formula sheet right here, I'm looking for arithmetic sequence formula, recursive, explicit. So this is the equation that I'm writing. Let's go ahead and copy that down. So this is a sub n is equal to a sub 1 plus d parentheses n minus 1. And we're going to quickly recap what each of those things mean. All right, this is going to be your first term. D is going to be your common difference or your constant rate. All right, that way you know both, right? So D is your common difference, your constant rate. A sub 1 is going to be your first term, and n is just the number of terms. Like, do I want the first one? Do I want the second? Do I want the third? Do I want the fourth? Do I want the fifth? Do I want the sixth? So remember, n always starts at 1. All right, so let me make that connection between I told you it's similar to linear and arithmetic. Remember, m is what? My constant rate of change, right? And I just said that the common difference and the constant rate of change is called d. So what I'm going to do is I'm going to draw an arrow from m to d. So in sequences, your d is your m, your slope. Okay, your b is where you start from, right? Where do you start from? And where do you start from in your sequences? Where n is equal to 1. So you're going to start at your first term. So this is your equivalent to your b. And then this in parentheses n minus 1 is going to be your x. So the only difference really between linear functions and arithmetic sequences, instead of them writing it in y equals mx plus b, they write the b plus mx. Okay, and I'll show you that in an example a little bit later on. All right, let's go ahead and write the recursive formula. So that was the explicit. The recursive one is this. The way I remember cursive, okay, if you write in cursive, all right, in order to write the next letter, you must have the one before because you connect everything, okay? So that's what recursive means. So a sub n equals a sub n minus 1 plus d. And the big thing that you need to realize is a sub n minus 1 means the term before. Okay, that's all you need to know. So what you're doing is you're taking the term before and you're applying the constant rate of change to it. So if the term before is 5 and the constant rate of change is plus 2, then you're doing 5 plus 2, like that. All right, so we'll go into detail when we look into an example. All right, so let's go ahead and look at an example really quickly. All right, so we've got, count the number of boxes. How many boxes do you see there? 3. How many boxes do you see here? 3, 4, 5. How many boxes do you see here? 1, 2, 3, 4, 5, 6, 7. All right, so we're going to put that in a table. So you're taking your pattern, you're going to put it in the table. So what term gives me number of boxes? 3, the first one. So remember, sequences starts at 1, functions start at 0. So this is not the 0, 1, this is the first one. So the first term is 3. Okay, the second one is 5. The third one is 7, so that must mean we skip a box. Each time, what are we doing to it? We're adding what? 2, which is the constant rate of change or the common difference. Okay, so we're adding 2 to it every single time. So this is going to be 4, this is going to be 5, and I'm going to ask you to find the 10th one. So the common difference is 2. And how do I know that? Remember, you take your second value and you subtract your first value. All right, once you find that, that is your constant rate of change or your common difference. All right, so let's write this in explicit form. So explicit form here is your formula right here. So we're going to write a sub n, the first one, is equal to a sub 1. What is the first term? Well, we know the first term is 3, right? The first term is 3 plus my common difference, which is what? 2. So this is 2, parentheses, and n minus 1. Okay, so now what we're going to do is we're going to go from explicit functions to function notation. I'm just going to show you the relationship of why they're the same. Okay, then I'm going to prove it to you. So I'm going to do it right here. So I'm going to do simplify this right here. So to simplify that, I'm going to distribute 2 times n, which is going to be 2n, 2 times negative 1, which is going to be negative 2. And out here we just have 3 plus, right? So when I combine like terms, 3 minus 2, that's going to give me 1. So this is going to be 1 plus 2n. And if I was to write this in function notation, I'm going to first show you that it's going to be the same thing as this. Only difference is instead of n, we have x. So if I was to write y equals mx plus b from this, I know this is number 1, 2, and 3, right? First, I'd find my slope, which is what's happening each time. What's my constant rate of change, which is 2. So my slope would be 2x. And then how would I find my y-intercept? Well, we know my y-intercept happens when x is equal to 0, right? I don't have x equals 0, I have 1 here. So I need to go backwards 1 more, right? So I need to go back here to 0. All right, so if I need to do that, what I'm going to do is my sequence is just going to need to go backwards like this 1 more. So I just need to find out when I go back 1 more, what is it going to be? Well, let's look at it. If I'm going forwards, 3 plus 2 is 5, 5 plus 2 is 7. How do I go backwards? I just take the opposite. 7 minus 2 is 5. 5 minus 2 is 3. So 3 minus 2 is going to be 1. So my y-intercept when x is equal to 0 is going to be plus 1. So you can see that this and this are exactly the same. The only difference is, of course, we have an n. So it's 2x plus 1. So writing this in function notation is going to be f of x is equal to 2x plus 1. So remember, the order doesn't matter because we're adding. So 2x plus 1. Okay, so that's function notation. Let's take a look at recursive. So looking at my recursive one right here, we're going to write a sub n is equal to the one before plus my common difference. So it's the one before, which is a n minus 1. My common difference is 2, so it's just plus 2. And what that means is we can find any term given the one before it. Okay, so now if you're finding my 10th term, you can either use explicit or function notation to find my 10th term. We can't use recursive because remember, to find recursive, you need the one before. So if I was looking for my 10th term, I'd need the 9th term and then add 2 to it, right? But I don't have the 9th term. So you got to use explicit or function notation. Please give me the 10th term. All right, you're also going to complete this problem underneath, but I'm going to go ahead and get you started. All right, Ben is picking flowers in the garden. He picks 51 flowers from the first bush. So here's the first bush, 51. All right, 41 from the third, 26 from the sixth, 6 from the 10th, and that's it. Okay, what kind of sequence it is? So first check if it's arithmetic because that's the one we're doing. So see if you can find the pattern as to what you're doing each time in order to get these numbers. All right, so that pattern should be exactly the same and it should give you all those numbers. And be careful here, it jumps from 10 to 13, so be careful with that. All right, so what is the common difference? So go ahead and find the pattern. How did you find it? Okay, and then give me the explicit formula. So again, you're going to use the formula that we wrote right here. Give me the explicit formula. Give me the recursive formula. Use this formula right here. And then what does P of 25 equal to and what does it represent? So you're also finding P of 13 and P of 25. Let's practice.